Hello, guys. Hello and welcome, guys, to the stream, Exploring Journey Towards Exciting Languages. With me, Ajinkya. And I'm Ajinkya. I work at Equal Experts. And before we start, uh, a few things about me. Uh, I've been working with JavaScript from the beginning of my web development career. And whenever I had time to learn something new, I did that in my free time at home. And this is the result of me uh, making a game in Golang. I'll just quickly show you what I built in Go, and then you'll have an idea. Okay, so this is the source code. It's also available on my GitHub account. The link will be shown in the description afterwards. All right, so I'm just quickly going to do the build. All right. So I'll just show you a few bits of my game, and then I'll talk further. All right. So basically, you have been kidnapped and kidnapped by a soldier. And the objective of this current state is right now I have to escape from this cave. Since I've built this game, I already know the clue. And also, the interaction key is a spacebar, and I'm moving with my arrow keys. So the clue is hidden inside this wall. Of course, definitely, I'm going to show the code, but let's just play through the game. Right? All right, so I have got the needed key into my inventory. And as soon as I cross this wall, I am being greeted by this NPC. Let's interact with him. Spacebar. Okay. Well, they'll just kill you just like others. Okay. So this is the clue. And if I keep pressing space, I'll be continuing the chat again and again. So I've already know the clue that she told me in the last chat, and just show you again. So we have to open the drain. All right. So now this is the cutscene again, storyboard kicking in. This is automatically a predefined cutscene, and it's again done automatically. And this filter which you see is direct C++ code added into Golang. All right. So our hero is outside of the cave, and there is a crate over here. So this is a chest. It has lots of items. Let's just pick them up. Okay, I'm hitting the spacebar. All right, so we can recruit 2 NPCs into our team. So Mrignani joins our team. Shashank joins our team. And if I press the left alt on my keyboard, I can see the inventory screen. Ignore the right-hand side XP bar. It's just still work in progress. And if I click on the equipment, I can equip them. I'll show you some interesting part over here. So currently, if you see, there is no weapon visible for Mrignani because she has a character of a mage. But if I go back and if I select Chandragupt, I can see a weapon because he's in warrior. So even though we have picked up all the items, only few of them are visible to certain character based on their character levels. And let's just equip bone armor. And I'm going to equip Magnani with accessories and Dragon's Club. All right. So let's get into the fight. And so we have 5 rounds to fight over here. At the start, user won't be able to beat all of them. There is a lot of grinding required. At the end of the round, you'll see there is an XP screen. So each round you gain XP, you fight again, you gain XP, and you unlock certain stuff. We are just going to quickly see that. All right. So just for this sake of demo, I have like boosted the players. I have also unlocked certain levels for the magic character. So as you can see, the magic option is available right away to our mage, which is not available by default. You have to level up. But I'm just going to show magic quickly over here. So magic utilizes the mana, and I'm going to use fire. And now the attacks are being queued up into the event, which you can see in the top left. And that's it. Okay. All right, so we won even before the mage got a chance. Okay, so I can skip this by pressing the space. Okay, and now this is the loot screen. So we have found heal potion from the enemy. So every time an enemy dies, they drop something. And all right, so let's go to the round 2. Why not? Okay, let's use magic again. This time electric bolt. And that. Right. Okay, this time we did not get any loot. But yeah, I'm going to stop the demo over here, and I'll talk about the code now. There are still more things over here. After beating the arena, you get a wins game over screen, and you also get to travel to the next level, that is the town map. You can check the whole code on my GitHub. I'm just going to stop this. And also, if you have noticed, while streaming, a lot of my CPU resources are already being used. But even though my computer was already being used by resources, Go build was really fast. So this is another feature of Go, that builds are really faster. And just quickly going to show you the code. Okay, so the interesting part over here is the storyboard, which you saw, which is available into game map. Sorry, I did not sort everything right away, but storyboard is over here. And but before I explain you this code, and maybe I talk about this code, I have created another shredded version of this game. I'll explain you in that. Okay, so this is a basic version of the same game. But before I explain anything further about my game, let's just see why I jumped into all this game development and why I learned Go. So as I already told you, I'm from JavaScript background. So learning something new for me was very difficult. In a way, I was always used to coding into JavaScript, and Go was kind of familiar to me, and that's why I chose Go. But the main reason of creating this game was in November 2019, I visited GDCR. And GDCR is an event where you have to go throughout the day. and I'll just show you what it is. And of course, again, these are the things which I'm going to talk. So uh, at GDCR, we were given the topic Game of Life. We could not finish it. So I thought, hey, why not? Let's just go home and uh, build the Game of Life using Go programming language. And that's how I built Game of Life into Go programming language. And quickly going to show you the code of Game of Life. I've already done a build over here. I'm just going to open that. Right, a fancy looking Game of Life. All right. So, okay. So currently, this is randomly generating. I'll just close this. I'm also going to walk through this Game of Life code, which I built in Go. Um, but there are a few things I have to explain further. Uh, all right. So, if you haven't heard of Game of Life, the rule is if there is any alive cell and it is surrounded by less than two alive cell, then it dies. If it has exactly two or three alive cell, stays alive. And if it has more than three cells, that means if it is overcrowded, it will die. Similarly, if it's a dead cell and if it is surrounded by exactly three alive cells, then it will come to life. Okay, so that was Game of Life. And uh, again, you might be wondering why I haven't why I haven't told you why I learned Game of Life. So if you're coming to the stream just now, I just mentioned I visited this GDCR in November 2019, and over there I got the idea of Game of Life. Again, since I'm not from computer science background, the Game of Life was completely new for me and had never heard of it. So that was something interesting for me. And again, since I love to play games, the word game got me excited. And that's how I built my kind of like a small simulation game into Go programming language. And that thing got me hooked to Go programming language. And I went ahead and I thought, why not build something more with the Go programming language? And now talk about. Correct. So I'll just talk about my Go code now. So this is my 2D game, 2D RPG game, which I built, but this is the shredded version of the same game, just so that I would be able to explain you a little bit better into this live stream. And few things which I liked about Go are there is a great support of Go into IDE. You can work either in Golang or maybe in Visual Studio Code or maybe in Sublime. So you don't have to have any special setup for Go programming language, and builds up blazing fast as you already saw. And Go is actually a true write once, run anywhere. Means if I build any code on my Windows machine, I can run it anywhere. Maybe I can run this on Linux, Raspberry Pi, or maybe on Macintosh, right? So uh, it builds up a binary. So I'm just going to open this file. And this is the build. I can even show you how did I build this. Okay. So I'm just going to delete this. And CDTV. Okay, I'm in wrong folder. And I'm just going to do build minus I utilizes your CPU properly and builds faster. Okay, I think I deleted wrong. And still, I will see this game of life. Oh, I'm in the wrong folder again. All right. So as you can see, there is no exe file. I can show you even in the folder. And I'm quickly going to do the build. That's it. Build is done. It's as simple as that. So you can already see over here, I'm not using much of the resources. I'm just using 11 to 12 MB of my RAM. That's the beauty of Go. It uses very low memory. I could even optimize it further. Like I have done a very basic Go code. But as you can see, this is a very tiled based layout. When I say tile based, this is actually a multi-dimensional array. And I've created this graphics using a sprite sheet and a tiled app. If I visit this, I can teleport, I can go back, I can teleport back again. So there is this collision. I cannot cross this. All right. So this was the little bit demo of the basic version of the RPG game. So let's talk about what I did over here. So any game, whether if you talk about 2D game, 3D game, whether you're writing into Golang, whether you're writing in JavaScript or maybe Rust programming language, there is always going to be a for loop, okay, which is over here. So your game is keep on going to run again and again into a for loop. And for the benefit of my CPU, I have like throttled down the for loop by this tick. So this loop runs every 60 times in 1 second. So in 1 second, it is running 60 times. Even that's really fast. It could run much more faster than this. All right. All right. So as you can see, the current version of the game which I showed you, this basic version, though it looks really simple, I'm just walking inside a map and just interacting with a automatic trigger. The code is still big, right? There are so many files. To maintain all this, I needed a pattern. I could not just go there, go into the code and write everything, every little bit entities anywhere, right? So after reading the book called Game Programming Patterns, I found there is a pattern called state machine, and which is what I have used into my game throughout the entire game. So I'm going to talk about it now. Also, about state machine, I could not find much of the things related to Go programming language over the internet. You can search, maybe you will find anything, but I could not find anything. And if you need help building games, hit me on Twitter. My Twitter ID is Ajinkya. So I'm going to explain a bit quickly over here, not briefly. Again, this code is also available on my GitHub account. You can go ahead and download it. So I'm just going to tell you how I built this state machine. So as you can see, there is this setup function. It is nothing but just a few variables initializations. Okay. So if you look at this hero character over here, this is my main character. It has few animation arrays. So if you look at my walk cycle, this is this image which is getting loaded inside the game, and I'm just playing through each of the frames. So if you are aware of CSS sprite sheets, this is exactly the same thing. Okay, and I've just defined which frame I want to load when I'm going up, which frame I want to display when I'm going to the right. Okay, and this is the facing direction, and this is the entity. This is the main thing, right? And if you see, I have defined an initial position of 4 and 4. Okay, so I'll just quickly show you again what I mean by that. So count from the left side, 0, 1, 2, 3, 4. There is another tile over here which is hidden right now, but 0, 1, 2, 3, and 4. So our character is sitting at x4, and from top also he's sitting at 4. 1, 0, 1, 2, 3, and 4. Okay, so you have to count from this wall, and in my game, the x-axis is on the top left. So this entity is being rendered. And where it is being rendered, it is rendered over here inside this for loop. This is the ticker, but this is still inside the for loop. All right. Now let's talk about this update and what is this M controller. Even if you're not understanding the exact code, just stick with me and just try to go through the code that this is how it is done and this is possible. Then you will get an interest building games, because it's very interesting thing to build games. Trust me on this. Okay, so this is my kind of a structure which is required for a state machine. I'll talk about state machine and I'll just show you in a graph. So in this example, I just created wait state and move state. And this is my state machine structure, which is consuming a map of state. State in our case is just an interface. If I go to this type over here, you will see state is just an interface. I'm not sure what you call that in Java, but in Rust it's called traits. An interface is nothing. It doesn't have any methods. It is just kind of a structure. It tells if any structure defines this function, then it is implementing the state interface. I'll talk further more, but I'm just going to show you in the graphics how it looks. All right, so state machine, I just said that I'm going to talk about wait state and move state. So in the wait state, the character, when it is in wait state, it is doing nothing. It is just standing, but it is doing a really important thing of waiting for the input from the user, right? And when it receives any input from the user, it goes to the move state, right? So we are just going to see that how it goes. All right. So I'm just going to show you the first. So what is state machine? It's a very simple code. State machine struct. If I have to talk about how this is in JavaScript, this is like a normal class, and these are all its prototypes. Okay, function which are sitting on its prototype, and this is its construct. Similarly, you might have the same thing into your Java code. So this is my initial class default values, and this is my constructor, or maybe you could say a static function which initializes this struct, and these are its methods. Okay. So my state machine has only three important functions: methods, change, update and render. So render, you can guess whatever the current value of the entity is, you have to just render that. Update, it will update, update. So whenever this state is being run, you are eventually going to this update of the current state. So what I mean by that, I'll come to that. Change is actually we are changing the state from move to wait, or either from wait to move. Okay, and let's see how I've defined it over here. I'm just storing this as an object literal kind of thing over here. So this is like a map, and the key is a string, and this is the type which is accepting. So it is accepting a function which returns a state. Okay, so these are my two things which are on my map. Okay, and initially setting the character to the wait state. So my character right now is into wait state. I'll just quickly draw that on a map. Also, when I'm in wait state, the code goes to this for loop and it just renders the current entity with its current values. It is just rendering, right? Every time it is just rendering. Okay, and I could have used controller.render, but I have used that in a later advanced code. But just for now, just stick with me and just note down that I am rendering the hero, and as well I'm updating the controller with the update method. So controller is a state machine, and state machine has something called current state. All right, so this current state is currently set to wait state, and whenever this update is being triggered, this is actually calling the wait state update method. And now we are inside over here. Over here, it is just waiting for an input from the user, that is the keyboard events. And as soon as a user hits the left arrow key, we are changing the state of this state machine to move. We are also passing the parameters. Okay, and when the user controller changes to move, we are going to the move state. And when the controller.change is being called, the state machine picks up that. We are calling this function over here. Okay, and we are exiting the previous state, exit current state, where is previous one, and we are replacing the current state with the new state. So in this case, it is going to be state machine move state, and we are also doing an enter. So current state dot enter. So this move state has to have a method called enter, which is over here. In the enter, we are setting the animation frames over here, but we are not actually rendering those animation. We are just setting the values of our entities over here. And then update function is being called over here. So based on the current state, we are calling the update method over here. And this is where it actually updates the animation keys. And it once the animation is finished, it is changing the state back to the wait. Okay. Now, if I have to show this in a diagram, I'll just quickly clear this. All right. So as you know, this was our grids. And our character is sitting at 0, 1, 2, 3, and 4. So our character was sitting over here initially, right? And there is this collision, user cannot pass. So when I'm initially over here, you already saw in the code that I'm setting the default value of the entity to be tile x4 and y4. So that is how the entity is being rendered over here. All right. And it is already set to wait state, which is happening over here. And I'm mentioning that the direction to move is 0 and 0. So when the direction is 0 and 0, I'll show you what is happening. So the current state is wait 0 and 0. User did not press anything. So the direction is 0 and 0. So he's just sitting here 0, y, 0. And as soon as if he presses the right arrow key on his keyboard, the x becomes 1 and y becomes 0. Similarly, if he goes up, the x becomes 0 and y becomes 1. Yes, in my code, sorry, x becomes -1. So in my code, as I mentioned, the x and y initially it is 0 over here. So on this side it is +1. When I go down, it is +1. Similarly, if I'm going up, it is -1 and it is minus on this side, it is x0 and y is -1. If I talk about this position, x is -1 and y is 0. So that is what I am doing over here in the code. Okay. And that's a kind of a short introduction to my RPG game. There is still a lot of things happening in the behind the scene. As you already saw, there is an animation thing happening. So if you have ever worked on Flutter, this animation transition would be familiar to you. And I did not even know about Flutter when I coded this. And but because of this code, it is really easier for me to work into Flutter because it uses similar concepts. And Flutter is actually a game engine which is being used to render Android applications and iOS applications. Okay, so that's it about the ORPG basic version. All right, you can just have some water. All right, so I'm going to show you Game of Life code into Go, and then I'm going to talk about Rust. So Game of Life is just to show you what it is again. Okay. Now we are talking about this Game of Life. And if you notice, this plus minus things are silly over here. So this was my first thing which I built. And I have utilized the same concepts and ideas into the 2D RPG game. Okay. So initially, when you start, since I've written this code into eBitten, okay, the previous code I had used pixel library. You will see there are similar concepts going on over here. Okay, this eBitten run is nothing but a forever for loop. Okay, and I'm just going to show you how the code is being initialized initially. So world is being created over here, a new world. It is just a simple struct which has cells. Okay, and cells. I'm just setting an initial capacity over here. Then I'm also specifying the width and height, which is the screen width and height. And I'm generating the grid over here. Okay. Once the grid is being generated, I'm calling a next function over here, which you can see over here. Okay. So every time this update is running, it's running again and again and again. Okay. And also printing to the world. So after print, I'm doing next. Next is actually updating the values. Now you can see I'm cloning the older world. Okay. I'm kind of using a method over here called next state. So next state is just checking based on how many neighbors it has. So should it stay alive or should it die? So this is what is happening over here. Okay. Also, if I talk about the generate grid again, so initially I'm just taking a percentage over here, which is, let's just say if I say 20%, so 20% of the cells will stay alive. So I'm initially creating a grid like this. I'm just showing you on the whiteboard. So initially, generate grid, what it does is, let's say if I have a grid of something like this. So 5 by 5. So I say 5 width and 5 height. So 25 cells. So I'm saying, let's say if I say 20% should stay alive. So I'm just going ahead and filling them with alive cells over here. Okay. And that is what this code is doing. It is just filling the entire 20% with a live cell. And then I'm doing a randomizing thing over here. So I'm randomizing based on a random method, which is inbuilt again to create all this, to create this game of life. I did not have to use any external libraries. Even to create the entire game into 2D, the 2D RPG game, which I showed you, I did not have to use a single external library. Everything is available to Go basic standard library code. The only library which I used was to load a map and the pixel just to use the SDL, I mean OpenGL. So anything which is rendering on your screen. Just for that purpose, I use pixel. And again, pixel is again built using Go programming language itself. Okay. So I'm doing the randomizing over here. So that is happening over here, generate grid. And every time I'm just printing them, and then in the next state, so it is just checking should the style stay alive or should it come to life. That's it. This is all Game of Life is about. The rules are mentioned, so I'm just trying to find out how many neighbors it has. So let's just so I'm passing it the current cells X and Y, and depending on the current X and Y's position, I'm checking each direction. I'm checking to the each direction. Does it have any alive cells or not? Okay. And I'm just returning the count. Okay. And let's just see the same code into Rust programming language. I'm just quickly going to show you this code again. Okay. So I'm doing a generate grid over here, filling all the 20% cells with alive cells. Then I'm randomizing them, like kind of scattering them. Then I'm checking should the cell stay alive or not. I'm also making a duplicate copy of the old one. Okay. Then I'm checking the neighbors and updating the cell state, updating that current cell on the grid. Printing is nothing but just it gets the character and renders to the screen. Okay. And these are some helper functions. Again, this code is available on my GitHub. And so now I'm going to show you the same code into Rust programming language. I'm going to close the Go code now. Okay. I'm now showing you the code Rust programming language. But before I talk about Rust, I'm going to tell you what are the nice things about Rust. Okay. And I'm just going to bring this window. I'm just going to quickly delete this few things. All right. So why Rust? Why couldn't I stick to Go programming language? Trust me on this. Go is still faster. It's amazingly easy to learn. There are few more things into Go programming language. I still yet to master them. One of them are sync pool, mutex, concurrency. Concurrency is easy, but there are still like complicated patterns which you need to learn, like considering the channels and everything. Again, I was happy with Go. I'm still happy with Go, but then few of the people over the internet they told me you should try game development in Rust because it is really good with memory stack and heap. Since again I'm not from computer science background, stack and heap, what is that? I don't know. So uh, I just started learning Rust and I figured it out. And I would say Rust told me what is stack and heap. So so this is a stack and heap example, really simple. And I'm creating a string over here, hello, and I'm just going to run this code. Uh, and maybe you will think, oh, this will work, but no, it won't work. Let's see why it doesn't work. All right. So Russ is already telling you that something is wrong over here. Move occurs because S1 has a type of string which does not implement trait copy. Ignore this part, okay, and concentrate on this mm, this error over here. It says value moved over here, okay, and again borrow here after move. Okay, what does all this means is so currently this string is not a fixed type. Okay, so when you create string from with this method, this string doesn't have a fixed, no fixed size, no fixed size. Okay, so if anything doesn't have a fixed size, will go to the heap. Okay, and will not be stored into stack. Now, what if this was just a string and say hello Ajinkya, and this would work fine. Why this is working fine? Because I've created a string literal over here, which has a fixed size. So if anything has a fixed size, if Rust compiler can figure out its exact size into the memory, then this code goes to the stack. Okay, and if anything goes to the stack, is always faster and easy to access. Okay, but if I convert this to a string, which is from this string struct, then this is not fixed size. Okay, I can go ahead and I can say s1 dot push underscore str, and I can say hello Ajinkya, and this would work. Again, if I run this code, this will give me an error because of mutation. I'm doing a mutation over here, mutable. By default, all the variables are immutable by default. So you have to specify them by this keyword called mute. And now if I run this, it would still fail. Uh, okay. Just for this quick fix, I'm just going to do a clone over here. And then it would work. Okay. So now I'm able to mutate this. I'm able to expand the value of hello. So that means initially on this line number 4, it doesn't have a fixed size. On line number 5, its size increases. Now, rather than me talking to you like on, let's just, why not just use a whiteboard and I'll explain you what I mean by that. Okay. So I'm just going back to our older example, which was failing. Okay. And I'm just going to copy this. And I'm going to go to the whiteboard. All right. So as I mentioned, we have something called stack, which is a smaller thing. Then we have something called heap, which is very big. Okay. And things which are on heap, they're stored like in chunks like this. Okay, I'm just going to copy them. Okay. So imagine we have this heat. Okay, I'm just going to say this is heat and this is stack. All right. So um, initially, as I told you that we have this code. I'm just going to say let S1 is equal to string from hello. And then we have another variable here over here, S1, S2 is equal to S1. And this wasn't working. So why this was not working, let's see that. So when you create anything which doesn't have a fixed size, something like this guy, this gets stored onto the heap. So if you count the characters, so we have 1, 2, 3, 4, 5. So this 5 character, they will go anywhere onto the heap. Okay, and there will be a pointer stored on the stack over here. Okay, so this will be stored over here, S1. So this S1 will be stored something like this. So it will have a length of 5, it will have a capacity of 5, and it will have a address. Okay, so when you are saying S2 is equal to S1, so Rust has a rule. If anything has a pointer, so in our case, this guy over here has a pointer which is S1. So one thing on a heap cannot have two pointers. So when we say S1, when we say S2 is equal to S1, so Rust tells you that there is an error. You cannot have two pointers pointing to the one thing. Okay, so these two guys cannot point to this one thing. Okay, this is not allowed. So this is a quick intro to stack and heap. So how do I solve this? You simply, when I create this variable S2, I can say I just need the address of S1 which is stored. So that is what we are going to do over here. So I'm going to say I give me just the address of S1 and this would run fine. Okay, and that's it about stack and heap. There are still more interesting things about Rust which I got to understand cause of Rust, and that's why I'm going to stay with Rust. So I know there are not many jobs related to Rust on the market. Why would one start learning Rust? But trust me on this. If you are a good Rust programmer, you can write a better C code. You can write a better C++ code. Maybe I can utilize the same techniques into JavaScript, and I can write better uh, JavaScript code. So the overall meaning of this talk is don't just learn languages because there are jobs or maybe you will find jobs with those languages. Learn from those languages. Learn for the sake of fun. So I got that fun learning by building games, and I learned something from them. So I'm going to, for now, I'm just going to stick with the Rust programming language. If you have more question, please post it in the chat. Also, you can message me on Twitter. My Twitter ID is over here, listed over here. Yeah, these are all the screens. And there are a few more things which I wanted to talk, but the time has exceeded. And you can find me on Twitter, Ajinkya X. I also run a YouTube channel called JS Punk, and the entire code is available on my GitHub account. That is github.com/steelex, and this is the link. All right, I'll also share these things into the chat. I will just open the chat where it is. There is one more thing which I would like to share with you guys. Okay, so please share your feedback on this link about the today's talk. In future, if you would like to hear from more from me, please do give me that feedback, and I would love to talk about more about Rust. And, this is the source code for my game. I'm also sharing that over the chat. And that's it. If I don't see any chat messages, I'm just going to stop the stream. All right, then. Thanks for watching, guys. You can message me on Twitter if you need any help. Bye bye.